Hello everyone. So today we'll discuss about simple harmonic motion or oscillation. So this is a topic of your rotational motion. So what we will discuss in this topic that what is the in general when अगर हम कोई स्ट्रेट लाइन के पाथ में जाते हैं या पैराबोलिक पाथ में जाते हैं तो इन दोनों में से डिफरेंस क्या है। सो ये जो स्ट्रेट लाइन पाथ हम जाते हैं इसका एक पर्टिकुलर वेलोसिटी होता है तो उसका पोजीशन भी हम टाइम के हिसाब से डिटरमाइन करते हैं। मतलब एक से पोजीशन जो है वो एक फंक्शन ऑफ टाइम के हिसाब से रहता है, ठीक है। तो हम क्या करेंगे यहाँ पर, so we will discuss in same case in similar to but in the rotational case. So what will be the position in rotational case and what will be the velocity in rotational case, what is the energy in rotational case. In the energy form we will discuss the potential energy, the kinetic energy. So what will be the expression for position, velocity, energy, acceleration in the simple harmonic case. So this is the simple harmonic motion. It is a rotational motion. Okay, rotational motion. Rotational motion in which we will discuss the time period, which is a function of time also. But what is the time period and what is the frequency? Then the position, velocity and acceleration. But first of all thing, again there is a angular frequency also, or angular velocity, we can say that one, that is represented by omega. So we will discuss all everything in this part. So in the first class, that is the so in first class we will discuss about these things. So simple harmonic motion is simple a rotational motion. But remember, we will discuss it is in a circular path motion. Okay, so rotational motion or circular path. We will consider the path as circular path, and we will discuss the position in this circular path. Okay, so first of all, again another thing, one parameter is also required, that is the angle, because in a circular motion the angle is changing. Okay, so why it is simple harmonic motion? Because in oscillation we will discuss simple harmonic motion, then damped harmonic motion, then post oscillation. So अगर हम देखेंगे कि एक पेंडुलम जो है उसको अगर कोई एक डिस्टेंस से लेके जाते हैं फिर उसको छोड़ देते हैं तो वो क्या होता है ना, ऐसे वो ऑसिलेशन करता है एक सर्कुलर पाथ में। वो एक आर्क लेंथ है, सर्कुलर का जो आर्क है, सो उसमें वो रोटेट करता है। अगर वो ऊपर की तरफ जा रहा है मीन्स इट इज मूविंग टू अपवर्ड, देन वी कैन कॉल इट एज 2, and it is moving to downward then pro, then again moving to upward then 2, then again moving to downward then pro. That means if this is a support, rigid support, and this is a pendulum. Okay, so this is a rigid support, this is a pendulum, we keep it to a distance, then drop it. Okay, then release it. It will when it is moving to downward, then that called pro. When it is moving to upward, then that is called 2, and this is called an equilibrium position. Okay, so this is equilibrium position. That means at this position the particle will be rest at certain time. Okay, so again it is moving to right side, and it is moving to, when it is moving to upward we call 2, when it is moving to downward it is called pro. So the 2 pro motion in a circular path or circular arc path is called as simple harmonic motion. But remember, if we will consider that case, that means अगर हम उस केस को देखेंगे कि हमारा जो वॉच, जो पुराना टाइप का जो वॉच है उसमें क्या होता है ना, पार्टिकल मतलब जो पेंडुलम है, अगर आप जो ओल्ड वर्जन का वॉच देखेंगे, पुराना वॉच जो देखेंगे, पुराना घड़ी, तो वो क्या करता है, वो ऐसे ऊपर जाता है, नीचे में जाता है, फिर ऊपर जाता है, फिर नीचे जाता है, लेकिन वो रुकता नहीं है। वो जब तक बैटरी ख़त्म नहीं होता है तब तक वो चलता रहता है। अगर हम देखेंगे सिंपल पेंडुलम लेके एक थ्रेड्स की तरफ से नीचे की तरफ लगा देंगे तो उसको थोड़ी डिस्टेंस पे लेके जाएंगे, फिर छोड़ देंगे, तो वो क्या होगा ना, वो रोटेट करेगा, फिर कुछ देर के बाद वो मेन पोजीशन में आकर रह जाएगा। सो यही हमारा मेन पोजीशन भी इसको हम ले जाते हैं, ठीक है। और जो मैक्सिमम डिस्टेंस तक जाता है वही होता है उसका एम्पलीट्यूड। सो एम्पलीट्यूड क्या है, वो जितना मैक्सिमम डिस्टेंस जाता है ये मेन पोजीशन से मैक्सिमम डिस्टेंस जितने तक जाता है तो इसको हम एम्पलीट्यूड लेते हैं। तो हम देखेंगे सर्कुलर के पाथ में इस पाथ को हम कंप्लीट करेंगे तो उसका मोशन को डिस्क्राइब करेंगे कि कैसे उसका पोजीशन होगा, ठीक है। सो इन दिस okay, so in this we will discuss that practical case. So when in one case we saw that in one case it is moving to promotion, then after certain time it come back to rest. And in another case like in our old person watch case, जो पुराना घड़ी है उसमें क्या होता है वो चलता रहता है। और एक केस भी होता है ओके, सो यही दो केस ही है, मतलब जो आता है फिर रुक जाता है मेन पोजीशन पे, और दूसरा वाला जो चलता रहता है, मतलब जो ऐसे वो टू प्रमोशन कर रहा है, फिर कोई उसको एक ब्रेक देता है, मतलब कोई एक रेजिस्टिव फोर्स देता है, तब फिर जाके वो मेन पोजीशन में रुक जाता है। मतलब ऐसे टू प्रो करता है, फिर धीरे धीरे उसका एम्पलीट्यूड जो होता है वो डिक्रीज कर जाता है। सो एम्पलीट्यूड डिक्रीज होने के बाद वो इक्विलिब्रियम पोजीशन में रुक जाता है, ठीक है। So it will come back to its equilibrium position after certain interval time due to a resistive force that known as the damping force. Okay, so this is free. This is simple harmonic. So there is no damping. Okay, no damping and no forced. This is simple. No external force. Okay, no external force. So in the simple harmonic motion we will discuss when there is no damping, that means no resistive force, कोई उसको रेजिस्ट नहीं कर रहा है, मतलब कोई उसको फोर्स नहीं दे रहा है कि तू रुक जा, थोड़ी देर ऑसिलेट होने के बाद तू रुक जा, ऐसा कोई फोर्स नहीं देता है। और ये जो फोर्स है नो फोर्स, एक्सटर्नल फोर्स कोई नहीं है, मतलब उसको कोई नहीं बोल रहा है कि तू अनलिमिटेड टू प्रो ऑसिलेट कर, मतलब अनलिमिटेड टू प्रो ऑसिलेट नहीं कर रहा है। मतलब जब वो रुक जाता है, मतलब जो मेन पोजीशन में जब वो स्टॉप हो जा रहा है तभी कोई एक्सटर्नल फोर्स नहीं देता है, ठीक है। तो एक्सटर्नल फोर्स कुछ भी नहीं है, डैम्पिंग कुछ भी नहीं है, ऐसे हम मोशन को क्या बोलते हैं, सिंपल हार्मोनिक मोशन। ओके, सो सच टाइप ऑफ मोशन इज नोन एज सिंपल हार्मोनिक मोशन। सो देयर इज नो डैम्पिंग, नो फोर्स ऑसिलेशन, इट ओनली रोटेट टू प्रो ऑन इट्स ओन वे। ओके, कोई बाहर से कोई फोर्स नहीं दे रहा है, कोई रेजिस्ट नहीं कर रहा है, कोई हेल्प भी नहीं कर रहा है, मतलब हम इसको थोड़ी देर बाद लेके जाएंगे फिर छोड़ देंगे तो वो टू प्रो मोशन करेगा। ओके, सो द टू प्रो मोशन, द टू एंड प्रो मोशन, so the two and pro motion when there is no damping or no external force okay, so such type of motion we call as simple harmonic motion. So why this is simple? Because there is no damping and no force. Why this is harmonic? Because this is two pro motion. The two pro motion is the harmonic and last one is the motion. Okay, so this is the introduction about simple harmonic motion. Okay, so now we will see what is happening when what is happening when it is motion. Okay, so let's derive the displacement vector and acceleration for simple harmonic motion. Okay, so let's choose a origin point. Okay, the origin point, and this is the amplitude. Okay, remember the motion is like this one. This is a simple pendulum and it is moving in two pro motion, and this is the in position. Okay, so okay, the pendulum is here and it has a mass small m and it is rotating in a circular path. Okay, so let us consider a pendulum of mass m and radius r. Okay, let us consider a simple pendulum of mass m and radius r, that means the amplitude is r, the radius is the amplitude, and it is rotating in a circular path. Okay, it is rotating in a circular path with velocity v. So let theta is the angle. Okay, so this is known as the arc length. This is known as the arc length. So we can say it is at L. Okay, so L is the arc length. So theta is the angle at time t. Okay, so y is the position, right? So y is the position. This is not y. Okay, this is the radius, but y is the position. Okay, so a simple pendulum. M is the mass of the pendulum. M is the mass of the pendulum, and theta is the angle covered by the pendulum at any instant of time. At any instant of time t. Okay, so theta is the angle. Okay, y is the position. Position at time t. Okay, so y is the position at time t, and L is the arc length. Okay, so L is the arc length. Arc length traveled. That means the distance traveled by pendulum at time t. Okay, so this is the these are the variable, that means the parameters we have used. So we know that, what do we know, that theta is nothing but L by R. So remember this formula, the theta is equal to L by R. So this is the arc length divided by radius. Okay, R is the radius और R is the amplitude. R को हम radius कह सकते हैं या amplitude भी कह सकते हैं. Amplitude. So R is the radius or the amplitude of oscillation. Okay, so let us consider a simple pendulum here having radius R. उसको बाद में हम amplitude बोलेंगे. So R is the radius now. So and it is rotating in a circular path with velocity v. Let theta is the angle covered by the pendulum at an instant of time t. Okay, so let L is the arc length traveled by the pendulum at time t. Y is the position at an instant of time t. Okay, so y होचे एक position में, मतलब okay, so let's this is p and this is p dash. So the pendulum is rotating like this. Okay, the pendulum is like rotating this. So this is 2 and this is 2. When it is back to origin, that is the pro motion, and when it is back to origin, so this is the pro motion. Okay, so these two pro motion I have compared with this circular path. Okay, so this is a circular motion. Remember, this is the path, that is the arc path in which actually the motion is on the PP dash. Okay, the motion is on the PP dash. So the motion is along P and P dash. Okay, so R is the amplitude. This means here R is the amplitude. So suppose at time t the particle is here, t1. At time t2 particle is here. At time t3 particle is here. Then again when it is moving to downward, this is another time, this is another time. So the position is along the PP dash, but the motion explained on this circular path. Okay, so let make a perpendicular here. Okay, if that angle is theta, so now I am clearly drawing this. So this is the motion actually. So we have this one, and this is the circular path on which the particle rotating. So this is the starting path. Okay, so this one is our theta, and this length is L, arc length. So if this one theta, you draw a perpendicular, and here a perpendicular, so that angle also theta. Okay, so and this position is y. So y is the position at an instant of time. So what we have discussed here, that the sine theta is nothing but, what is sine theta? So that is p by h, right? So y by r. So what is y? So y equal to sine theta. So remember, So this is the position at an instant of time. Y equal to r sine theta. Okay. So this expression gives you the position. Okay. Remember perfectly the diagram that the particle is oscillating on two pro motion, but we have derived this two pro motion. That means the arc path is completed in a circular path. ओके सो इसको हम एक सर्कुलर पाथ ले जाते हैं, मतलब उसका जो ऑसिलेशन है वो सिर्फ पी और पी डैश में होगा, ठीक है। पी और पी डैश जो है वो उसका ऑसिलेशन पाथ है। सो एट एनी इंस्टेंट ऑफ टाइम, एल क्या है, आर्क लेंथ एट एनी इंस्टेंट ऑफ टाइम ऑन दिस टाइम व्हाट इज द पोजीशन, दैट मीन्स व्हाट इज द वाई। सो इफ यू लुक टू दिस डायग्राम at if this angle is theta at any time t, okay, at any time t, then that angle also will be theta due to mathematics properties, geometry properties. So sin theta equal to y by r, that the y equal to r sin theta. Okay, so this is the position at any instant of time. Again, what's happening, we have a parameter, that is the angular frequency, or you can call it as angular velocity. So what is the angular velocity? Okay, you complete it, angular. So that is omega, and this is nothing but theta by time. Okay, so what is angular frequency? This is the angle covered at an instant of time. Okay, angle covered at time t. At time t. Okay, so this is the definition of your angular frequency. So theta equal to omega t. Therefore, that is the expression of y now. So y equal to r sin omega t. So remember, this is the position for a simple harmonic motion when there is no damping and when there is no external force. कोई भी damping नहीं है, कोई भी external force नहीं है। तो damping क्या है, external force क्या है, ये पहले समझा दिया आपको। So अब हम देखेंगे। So this is the position, right? Okay. So now we will discuss what is the velocity. So what is the velocity expression? What will be velocity expression? So remember, two new things I have told you, that is the theta. Theta is nothing but the arc length divided by radius. Remember, this is L by R. So what is the velocity? Remember, velocity is the time derivative of position. Okay, velocity is the time derivative of position. That means change in distance divided by change in time divided by dt. Okay, so if we will do the derivative, remember the derivative of sin theta equal to cos theta. So I am doing the rough work here. You try to remember this. So what is the derivative of sin theta? So remember, this is theta and there also theta. We have taken the derivative with respect to theta, right? So the derivative will be cos theta. But when we will derivative with respect to t, remember there is sin theta but there is t. So what will be answer? Cos theta d theta by dt. Because the variable is not theta here. The variable here theta, but here the variable is t. So the derivative will be cos theta and again multiplied with d theta by dt. Okay. So remember, here also same thing. The derivative, that is d by dt of y. What is y? Y equal to r sin omega t. Okay. Remember, the derivative is with respect to t. Okay. So derivative with respect to t. And what is r? R is the amplitude or radius. We can call r as amplitude. Okay. R here amplitude. So remember, the first variable that connect with the sign is known as the amplitude. That means the maximum distance covered. What is amplitude? The maximum distance covered by the pendulum during simple harmonic motion. This is the maximum distance. So what is y max? Y maximum is known as the r, that is the amplitude. Okay. amplitude. So this is the maximum distance, that is the amplitude. Okay, so the velocity, you do the time derivative. So this is the r, that is the radius constant. So the constant will be outside. That means d by dt of sine omega t. Okay, so what is sine derivative of sine omega t? Remember, there is not only t, there is also omega. t के पास कौन बैठा है? ओमेगा. यहाँ पे सिर्फ t नहीं है, यहाँ पे ओमेगा है. सो ये तुम्हारा थीटा है. सो पहले हम भी देखे थे. सो थीटा क्या है? sin omega t. So what will be answer? r cos omega t into d by dt of omega t, according to mathematics properties, derivative properties. This one, if the variable is t and okay, so the variable is t and you are differentiating theta, then answer will be cos theta d theta by dt. If the variable is same, then we don't require d theta by dt. So what will be the velocity expression now? So the velocity will be r omega cos omega t. So remember, this is the expression of velocity. So this is the distance y equal to r sin omega t, and the velocity r omega cosine omega t. Okay. So if we look the velocity expression, that will give you. So remember, what is v? That is r omega cosine omega t. So what is cosine omega t? We can write it as 1 minus sine square omega t. Right? What is sine square omega t? What is sine square omega t? So this is nothing but y by r. What is sine omega t? Y by r, because y equal to r sin omega t. So sine omega t equal to y by r. Therefore, what is sine square omega t? That is y square by r square. So you do the mathematics, so that answer will be omega into r square minus y square root over. Okay. So this is the expression of velocity in terms of your radius, position, and angular velocity. Okay. So this is another expression of velocity. So v equal to omega into r square minus y square square root. One square root is there. Okay. So what is the maximum value of velocity? What is the maximum value of velocity? So remember, this is equal to r omega. Because what is the maximum value of cosine? What is the maximum value of cosine? We know that minus 1. So its range is minus 1 to 1. So the maximum value is 1. Okay. Hence the maximum, if cos omega t is equal to 1, then what will be the maximum velocity? R omega. And this is the amplitude of the velocity. Okay. So this is the velocity amplitude. So remember, r omega is the velocity amplitude, r is the position amplitude. Okay. So next we will go to acceleration. Okay. So I am removing this part. So what is acceleration? Again, we will go to the time derivative. So what is acceleration? So this is acceleration. Okay. So what is acceleration? This is nothing but the time derivative of velocity. So you do again the derivative. What is the derivative of velocity? So velocity is nothing but r omega cosine omega t. Okay. So again, your derivative is with respect to t. लेकिन यहाँ पर सिर्फ t नहीं है, यहाँ पर ओमेगा भी है जो cos के साथ है. r ओमेगा, सो ये t के साथ रिलेटेड नहीं है, तो ये बाहर चला आएगा. सो r ओमेगा, that is d by dt of cos omega t. So what is the derivative of cos theta? This is nothing but the minus sin theta. But again, you have to derivative with respect to t of omega t. Okay, so this is also another formula. That is the derivative of, if d by d theta of cos theta, then that will be minus sin theta. Here theta, here also theta. But if you do the time derivative with cos theta, then your answer will be minus sin theta d theta by dt. Okay. So this is the derivative of theta with respect to theta. So there will be no change. So answer will be minus sine theta. But when you are doing the derivative with respect to time, then there will be chain rule. This is called chain rule. Okay, minus sine theta d theta by dt, because यहाँ पे थीटा नहीं है, यहाँ पे t है. Okay, so next we will go to acceleration. So this is the formula of acceleration. So what do you obtain? From this case, omega will be outside and dt by dt is 1. So omega, 1 omega is there. So that is minus r omega square sine omega t. Okay, so minus r omega square sine omega t. Again, what is so what is our position? हमारा position क्या था? So हमारा position क्या था? Y equal to r sine omega t. Okay, so ये हमारा position था कि y equal to r sine omega t. So r sine omega t will be y. So that means minus omega square y is our acceleration. Okay, so one negative sign is there. So that negative sign means when you are moving in two motion, that means you are moving to upward, then that will be negative side, and when you are moving to downward, that means towards the position, that will be positive sign. Okay, I will discuss the sign convention for y. What will be the sign convention for y? Okay, so this is the acceleration of simple harmonic motion. So what is the maximum value of y? What is the maximum value of y? Y equal to r sine omega t. Before 10 minutes we have discussed this position, that y equal to r sine omega t. So what is the maximum value of y? Sine का जो maximum value है वो है 1, cosine का maximum value 1, sine का भी maximum value 1, क्योंकि ये हम रेंज में पढ़े हैं कि -1 के अंदर साइन का वैल्यू रहेगा. ठीक है, सो y मैक्सिमम होता है r. देयरफॉर एम्पलीट्यूड मैक्सिमम क्या होगा? सो दिस होगा माइनस ओमेगा स्क्वायर r. दैट मींस मैक्सिमम, सो माइनस साइन विल नॉट बी देयर. सो दैट इज द वैल्यू ऑफ योर acceleration maximum, r omega square. So what is the maximum value of amplitude? That is r omega square. Okay, so this is the value of amplitude maximum. Okay, so I am briefly described again. So what we have discussed, the simple harmonic motion. What is simple harmonic motion? So this is a simple harmonic motion, that is the two-flow motion when there is no damping and when there is no external force. That motion, that circular motion path is known as simple harmonic motion. So that is two-flow motion. Okay, so the particle is vibrating along the mean position. The particle is vibrating along the mean position. So this is mean position, and when it is moving to right 2, then again back 2, then again left, so that is 2, then again back, so that is 2. Okay, so the particle is vibrating along the mean position. Such type of motion is known as simple harmonic motion. So ये हॉरिजॉन्टल में हम देखेंगे या पेंडुलम में देखेंगे, तो कहीं पर भी वो सिंपल हार्मोनिक कर सकता है. ठीक है, सो व्हाट इज द पोजीशन? y equal to r sin omega t. Okay, what is the velocity? So that is r omega cosine omega t. And what is the amplitude? That is minus r omega square. Sorry, minus r omega square sine omega t. Okay, so what is the another expression of velocity? So that is okay, so another expression is that omega into r square minus y square root over, and another expression of amplitude is that minus y omega square. Okay, so these are the things we have studied. Okay, so this is the and some maximum values also there, and which we have seen the various cases. So v equal to omega into r square minus r square, and what is the maximum value of v max and what is the minimum value of v? So that we will discuss. So what is okay? So remember, so this is the r omega cosine omega t, right? So what is the maximum value of velocity? V maximum. b मैक्सिमम कब होगा, जब cosine ओमेगा t मैक्सिमम होगा. So what is the maximum value of cosine omega t? That is 1. Hence the maximum value of velocity is r omega. What is the minimum value of velocity? So that is 0. Because cosine pi by 2, cos 90 is 0. If you look to the value of the cos, so what is the value of cos? So these are the things we have discussed. So remember, the velocity is nothing but r omega cosine omega t. R is the radius, so this is constant. Omega is the angular velocity, this is also constant. So depend upon cos omega t. If you look to the cos omega t range, what is the maximum value of cos omega t? Maximum किसका, cos का, वो है 1, और मिनिमम क्या है, वो है 0, क्योंकि वो नेगेटिव यहाँ पर नहीं होगा. क्योंकि ऑसिलेशन कर रहा है तो वेलोसिटी हम उसका मैग्नीट्यूड लेते हैं तो वो मिनिमम नहीं होगा, इसलिए b जो मिनिमम वैल्यू है वो है 0. सो व्हाट इज द मिनिमम वैल्यू ऑफ b? दैट इज 0. ओके, इफ यू लुक टू दिस केस दैट b इक्वल टू ओमेगा, अगेन अनदर एक्सप्रेशन इज दैट ओमेगा इनटू r स्क्वायर माइनस y स्क्वायर. इसको हम देखेंगे तो समझ में आ जाएगा. सो व्हाट इज r? r इज द रेडियस. व्हाट इज y? y इज द पोजीशन. If you look to the circular path from where we have discussed the position, so the particle is moving in this path. So this is to fro, okay, so this is 2, that is moving upward, then moving downward, this is fro. So and this is the radius and this is the position, okay, y at any instant of time. Suppose 2 सेकंड के बाद यहाँ पर है, 3 सेकंड के बाद यहाँ पर है, 4 सेकंड के बाद यहाँ पर है, फिर 5 सेकंड में वो रिटर्न कर रहा है, फिर 6 सेकंड में यहाँ पर आएगा. सो y मैक्सिमम कितना हो पाएगा, वो हो जाएगा r. y मिनिमम कितना होगा, हो जाएगा 0. मतलब यहाँ से वो कहाँ तक जाता है वही है y. यहाँ से अगर ऊपर जाएगा तो प्लस y, यहाँ पे अगर नीचे जाएगा तो माइनस y. ठीक है, अगर वो मीन पोजीशन से दूर चला जाता है, मतलब ऊपर की तरफ चला जाता है तो y हो जाएगा नेगेटिव. ये साइन कन्वेंशन है. सो व्हाट इज द साइन कन्वेंशन? सो व्हेन y इज मूविंग टू अपवर्ड, टू मोशन कर रहा है तो वो पॉजिटिव होगा. अगर y मूविंग डाउनवर्ड की तरफ आ रहा है, मतलब मीन पोजीशन की तरफ आ रहा है, तो क्या हो जाएगा, वो फ्लो हो जाएगा एंड वो हो जाएगा नेगेटिव. ओके, सो y यहाँ पर क्या कर रहा है, 2. जब मूव अपवर्ड जब जा रहा है तो 2, जब नीचे आ रहा है तो फ्लो. अगेन मीन पोजीशन में 0. व्हाट इज द वैल्यू एट मीन पोजीशन? 0. What is the value at the amplitude? Okay, so this is the amplitude, that is the maximum. You suppose these things, that suppose this is the mean position. So here y 1 centimeter, here y 2 centimeter, here y 3 centimeter. Again it is moving to mean position, so y is 0. When it is moving to here, again 1 centimeter, again 2 centimeter, again 3 centimeter, then again to 0. So जब 2 मोशन कर रहा है, मतलब वो मीन पोजीशन से दूर चला जाता है, तब पॉजिटिव है. ये ऐसा नहीं है कि वो नीचे की तरफ जा रहा है तो नेगेटिव, ऐसा नहीं है. वो मीन पोजीशन से दूर चला जाता है तो वो पॉजिटिव है. अगर मीन पोजीशन की तरफ आ रहा है तो वो नेगेटिव है. ठीक है, सो द मिनिमम y इज नॉट माइनस r. ओके, y मिनिमम इज 0. देयर इज नो माइनस r. Okay, when it is moving to, that means when it is moving to downward, then that time the position will be minus. Okay, so this is the sign convention. That's why what is the maximum? Y r. When y is maximum, your v will be minimum. Remember this. When y maximum, v minimum. Because y maximum कितना है r. अगर यहाँ पर हम r substitute करेंगे तो v का वैल्यू क्या आ जाएगा? 0. When y maximum, your v will be minimum. When y minimum, your v will be maximum. So what is the maximum value of v? So this is nothing but r omega. What is the minimum value of y? So that is 0. So these are the important things. When y is maximum, v will be minimum. when y is minimum, v will be maximum. Okay, so these are the case. And what is the amplitude? That is minus I y omega square. So what will be the amplitude maximum? Okay, so these are the case. So you remember. Okay, so amplitude maximum, that also depend upon y. So y what? So amplitude maximum is r omega square, and amplitude minimum is 0. So this also depend upon your y. Omega is a constant. This depends upon y. What is y maximum? R. You substitute, so that will be r omega square. What is y minimum? That is 0. So acceleration minimum is 0. Okay. So these are all things about the position, the velocity, and acceleration of a simple harmonic motion. So what is the kinetic energy? Remember, we have three energy. That is the kinetic energy, and the potential energy, and total energy. What is the kinetic energy for a simple harmonic motion? So we have discussed in the simple harmonic motion. So what is the energy form? Okay. What is the energy form? Okay. So we will discuss about the energy things for our motion system. Okay. So to derive these things, we have to know one more things. Okay, so forget about the total energy, we'll discuss later. So what is kinetic energy? Remember, kinetic energy formula जो होता है वो है half mv square. So what is half mv square? What is the expression of v? Previously we have discussed that v equal to omega into r square minus y square. That's root of. What is y? Y equal to r sin omega t. Okay, what is velocity? So this is r omega cosine omega t. Right. So what will be our kinetic energy? So that is equal to half m v square. What is v? So that is omega square into r square minus y square. So this is half m omega square into r square. Sorry, half m omega square r square minus half m omega square y square. So this is the expression of kinetic energy. Okay. So what is potential energy? So remember, we can denote it as U. Potential energy को हम U से represent कर सकते हैं. तो एक formula है. So what is actually force? What is force? This is the negative gradient of potential energy. So force is nothing but the negative of potential gradient. The d by dr is called as potential gradient because the derivative is with respect to the position. Okay. So force is equal to the negative of potential gradient. So what will be the formula for you? Remember, this is the integration of FDR. What is FDR? Okay. So remember, the potential energy is the integration of F into dr. What is F? F is known as the force. Okay. What is force? Okay. So this is the kinetic energy, half m omega square r square. Now we will discuss about the potential energy. So remember, the potential energy is the negative of negative integration of force, because force is equal to the negative of potential gradient. You try to remember this. F equal to minus du by dr. So F into dr will give you minus du. Hence U is the integration of minus FDR. Okay, so this is the potential energy. We can express as is U terms. So what is the expression of force? So force is mass into acceleration. Remember, what is R? In our motion, in our oscillation system, R is the radius, which is constant. But the position is changing. What is the position? This is Y. Y also a parameter of length. R also a parameter of length. But here R is constant. Therefore, the position that will be dy. Okay. So this is the integration rule for potential energy. Because the R is position. R Y सेम नहीं है, लेकिन जब वो कंप्लीट ऑसिलेशन कर लेता है, मतलब जो मैक्सिमम पोजीशन तक जब रीच करता है, तो Y R के साथ इक्विवेलेंट हो जाता है. R जो है वो एम्पलीट्यूड है y जो है वो पोजीशन एट एनी इंस्टेंट ऑफ टाइम, मतलब 2 सेकंड के बाद कहाँ पर होगा, 3 सेकंड के बाद कहाँ पर होगा, वही डिटरमाइन करता है y। लेकिन r जो है वो मैक्सिमम कितने दूर तक चला जाएगा, इसलिए r जो है वो कांस्टेंट है, तो हम वेरिएबल किसको लेंगे, y। ठीक है। सो व्हाट इज द एक्सेलरेशन m, व्हाट इज द एक्सेलरेशन, previously we have studied that acceleration equal to minus omega square y. Acceleration, what is acceleration, minus omega square y. This is the acceleration, minus omega square y, so that minus will be plus, and integration with respect to y. So when you are doing the derivative, sorry, integration with respect to y, other values are constant, so that will be outside. So omega square y, integration of y dy, if you study integration, so then you will understand, so that will be half omega square y, sorry, y square. What is the integration of y dy? So integration of y dy is nothing but half y square. Okay. So this is the expression of potential energy. So this is the potential energy. So remember, this is the potential. Now you come to the kinetic energy. Okay. So this is half m omega square r square minus, what is this value? This is the potential energy. And what is this one? This is the kinetic energy. So kinetic energy plus potential energy, इसका वैल्यू कितना आएगा, half m omega square r square, which is nothing but the total energy. So the total energy is half m omega square r square. So this is the expression of total energy. Okay. So finally we have discussed all energy systems for simple harmonic motion. So what we have finally discussed, that the potential energy is half m omega square y square. और हम इसको भी जानते हैं कि पोटेंशियल एनर्जी का दूसरा फॉर्मूला क्या है, mgh, मतलब वो हाइट के ऊपर डिपेंड करता है, पोजीशन के ऊपर डिपेंड करता है। यहाँ पर भी पोजीशन के ऊपर डिपेंड क्या है, जो कि y है। ठीक है। और जो काइनेटिक एनर्जी है, वो काइनेटिक एनर्जी कितना है, हाफ एम वी स्क्वायर, और उसका एक्सप्रेशन क्या है, हाफ एम ओमेगा स्क्वायर इंटू आर स्क्वायर माइनस वाई स्क्वायर। ओके। सो व्हाट इज द काइनेटिक एनर्जी मैक्सिमम वैल्यू, काइनेटिक एनर्जी का मैक्सिमम क्या होगा, फिर से ये y के ऊपर डिपेंड करता है। सो y का मैक्सिमम कितना है, r है। जब y हो जाएगा मैक्सिमम, सो काइनेटिक एनर्जी हो जाएगा मिनिमम। सो व्हाट इज द मिनिमम काइनेटिक एनर्जी, दिस इज 0। व्हाट इज द मैक्सिमम काइनेटिक एनर्जी, दिस इज हाफ m ओमेगा स्क्वायर r स्क्वायर। तो ये कब होगा, जब y हो जाएगा 0। जब y हो जाएगा 0, ये जब y हो जाएगा r। Then what is the expression of total energy? This is nothing equal to half m omega square r square. What is r? R is the amplitude of oscillation. R is the amplitude. Okay. So total energy equal to half m omega square, जो है काइनेटिक एनर्जी का मैक्सिमम। अगर पोजीशन नहीं रहेगा तो पोटेंशियल एनर्जी नहीं रहेगा। सो व्हाट इज द पोटेंशियल एनर्जी मिनिमम, पोटेंशियल एनर्जी मिनिमम कितना है, 0। जब y 0 हो जाएगा, सो तो इम्पोर्टेंट थिंग इज y। व्हाट इज द y मैक्सिमम, व्हाट इज y मिनिमम। y मैक्सिमम कितना है, वो एम्पलीट्यूड जितना है, y मिनिमम कितना है, 0 है। ठीक है। सो दीज आर द पोटेंशियल एनर्जी, टोटल एनर्जी and your kinetic energy. Okay. So this is all about your energy system. Now we will discuss what is the time period for a simple harmonic motion. What is the time period for simple harmonic motion? So what is time period actually? So in a general case, if you know that the particle is that means the pendulum is moving to fro, okay, to then fro, then to, then fro. So if you look one oscillation, this is to, this is fro, this is to, this is fro, then that will complete a circle. Yes or no? So this is started here, okay, so let this point is P, to, then fro, then to, then fro. That means this is quarter circle, that means 1/4 of circle. ये 4 भाग से 1 भाग है सर्कल का। 2 फिर से प्रो, हाफ सर्कल हो गया, फिर से 2, फिर से 4, हाफ सर्कल हो गया, हाफ हाफ कंप्लीट सर्कल हो गया। लेकिन जो पोजीशन है वो इस डायरेक्शन से मूव कर रहा है, मतलब P और P डैश, P और P डैश इस डायरेक्शन से मूव कर रहा है। उसका ये पाथ है, लेकिन जो मोशन है, जो Y है, वो एक मीन पोजीशन है वहाँ पे। फिर ये जो है वो उसका पोजीशन है, मतलब 2 सेकंड के बाद यहाँ पर, 4 सेकंड के बाद यहाँ पर, तो वो ऐसे पोजीशन देना है। सो जब वो एक कंप्लीट सर्कल कर लेगा, मतलब एक सिंपल रोटेशन, यहाँ से जाएगा, फिर यहाँ से पहुँचेगा, फिर यहाँ से जाएगा, फिर यहाँ से पहुँचेगा, उतना जितना टाइम लगता है उसको बोलते हैं टाइम पीरियड। मतलब टाइम पीरियड इज द टाइम टेकन टू कंप्लीट ए सर्कल। व्हाट इज टाइम पीरियड? दिस इज द टाइम टेकन टू complete one oscillation। तो इसको हम और भी कर सकते हैं, टू complete one closed path। Okay, one closed path. This is the time taken to complete one oscillation, to complete one complete oscillation, or to complete one closed path। यहाँ से जाकर फिर से वहाँ पर पहुँचने के लिए जितना टाइम लगेगा वो है टाइम पीरियड। सो तो वो टाइम पीरियड कैसे रिलेटेड है? सो हम एक एंगुलर फ्रीक्वेंसी देखे थे जिसका वैल्यू है θ/t। सो जब ये जो स्मॉल t है वो 2 सेकंड के बाद कितना, 3 सेकंड के बाद कितना, पर जब कंप्लीट रोटेट कर जाएगा, व्हाट इज टाइम पीरियड? दिस इज द टाइम टेकन टू कंप्लीट ए सर्कुलर पाथ, टू कंप्लीट ए closed path। so when t equal to t, यहाँ से यहाँ, what is the radius? this is r। so वो यहाँ से 2 pi, because the angle covered to complete a circle, पार्टिकल कितना एंगल जाएगा, यहाँ से जब थीटा 0, यहाँ पे 90, 180, 270, 360। so to complete a path, to complete a circular path, कितना एंगल जाएगा? 360 डिग्री। so 360 डिग्री by t। जब ये t कंप्लीट t हो जाएगा, सो एंगल हो जाएगा 2 pi। ओके, सो दिस इज द, सॉरी द मिस्टेक इज दैट, सो टाइम पीरियड इक्वल टू 2 pi by ओमेगा। ओके, अगेन ओमेगा फ्रॉम दिस acceleration का to one negative sign there is there, but this negative sign is due to y। this implies omega equal to a by y root over, what is omega? that is 2 pi by t। so what is the another expression for t? so t equal to, remember, 2 pi into y by acceleration का root over। so remember another formula is there। so t equal to 2 pi, what is y? so this is position, what is a? so this is acceleration। so t equal to 2 pi into square root of position by acceleration। so remember these two formula, t equal to 2 pi by omega and t equal to 2 pi y by a। r will not be there because this is the angle, okay, not distance, this is the angle। मतलब कंप्लीट सर्कल के लिए कितना एंगल करेगा, so that will be 2 pi। okay, so these are all about position, velocity, acceleration, energy and time period। in next class we will discuss the time period for a simple pendulum। okay, so अगर कोई मिस्टेक है या कोई कुछ अंडरस्टैंडिंग में मिस्टेक है तो please comment and share it and like also if you like it, then subscribe the channel so that it will motivate for further video, and share it so that all of will be helpful। okay, so we'll stop here।